show on Game Tools 2020. Oh, it does say 11 messages.
I guess the game meeting's probably communication code.
Wait, what?
It's PDF. Final brief. Final brief.
Says final.
Good morning. I see you found the project brief.
I typed that like 200 words.
Yeah, I'll get to the project at the end of the class. Let's start with the review of the review of the lab test. So you should have gotten your results. Let me know if you haven't. So let me just set up. Can everybody hear me okay?
Yep.
All right. Can you see my screen? Good stuff. Okay, like I said, the final solution is now on the main project GitHub. So hope you were able to find that. Let me just find you again. I overheard there was a question about the branches. Was there something unclear about that? By default, the master branch is the one you're interested in. So now I'm on the Game 2004 repository and branch master. And if you pull that, or if you clone it to your machine, you can download the zip as usual. The Scene 7 will have the full solution. But what I'm going to do is I'm going to start from the initial version of the scene again and just go through the solution really quick. Like, we shouldn't need more than 15 minutes to really go through this.
Are you recording this class?
I am recording this class, yeah. Okay, so starting with problem one, the idea there was to just play with the building blocks that we've already set up for the city. So there was quite a complex system that I've set up. Well, part of the reason why it is complex is actually to make it easier for you to build your final project. So you don't have to worry about the template and the framework to create something that is a complex enough city scene. So okay, so let's see. You've already been provided with the wall profile, which was the scriptable object containing some information for building the buildings the way we want them. So let's have a look at that. In problem 1, the scriptable object is provided for you already filled in. In problem 2, you were supposed to create a new one for the tree building. So just a quick question. Is the scriptable object idea still confusing or giving anyone problems?
What do you mean?
Yeah, the scriptable object. I've noticed that there were a couple of students who, for example, tried to instantiate the wall profile. So that made me think that not everybody is necessarily.
I tried to do that, yeah.
Okay, so yeah, okay. Well, let us have a look here. I'm here on the pro. Okay, so, sorry. Okay, my feed preview wasn't refreshing, so I wasn't sure if I'm seeing this. Okay, so if I go to any of these assets, the tower profile or wall profile, these are in the data folder. So these are the scriptable object instances that we use for different buildings in our game. So let's go to our wall profile and just hit edit script, just to remind ourselves what exactly this stands for. Okay, let's give it a chance to open. So if you look inside that building profile CS, the script, it defines our scriptable object. It is not a monobehavior class, it is a scriptable object. The only purpose of it is to hold some data for us. So this could have been done in many other ways, obviously, but scriptable objects have this benefit that you can edit them at runtime. So our game can use these the data which is contained within each of these assets to do something, and we don't actually need to stop and restart the game to change some values, and also we don't need to put a million of different fields in the inspector on our components. So for example, I could have created a tree tower block script, a component, which would have all this information in arrays contained within this script. But then I'd have to edit that for all the blocks, all the building blocks that are in the scene. Maybe I want to do some differently, so that was kind of that would have fallen over pretty quickly. So this is just to kind of like give you a big picture why we even bother with the scriptable objects. Well, I found them very useful in in game development in many situations. So I figured, okay, this is actually a practical trick or kind of a tip that actually will be helpful for you. So the sooner you kind of get your head around things like scriptable objects, for example, the easier it might be for you to create more complex setups. So let's carry on with the problem. The actual idea there was to build the wall. Okay, and as it states here, all you need to do is write a few lines of code using a for loop, and also it states you need to use the instantiate and set profile methods. So one of the reasons I've set these problems like this was okay, I didn't want to test necessarily your coding skills at this stage, but I did want to see if you're following the course lecture and spending a little bit of the time with the code to understand it. So both instantiate and set profiles were methods that we've created in class. So okay, so give me a reminder, please. What is instantiate for in this case? Well, let's actually have a look. Okay, if you don't remember where that was, you can just do a quick search. We should be able. Yeah. Okay. So it found it for us. It is in Tree Tower block, which is not the one that we're looking for right now. We're still in the recursive tower block. Now let me see. Okay, this should be in Deluxe Tower block. I searched for within open documents only, so that was my bad. The Deluxe Tower block is the one we're currently using here for building the wall. So let's have a look. Okay, so I can see that instantiate is already being called quite a lot within tower blocks itself. If you recall, this whole tower block construction is based on recursion, that we place one block and then it places the next ones. Again, why I went for this kind of construct is that this allows us to create complex buildings without really trying too hard and worrying about too much complexity. It does seem a little bit complex, but if you follow through with the code, hopefully you will understand what's going on there. And most of you did, looking at the results. Just, Okay, my apologies. I think I am still a little bit in the wake-up process. Obviously nonsense. Okay, so instantiate obviously is the standard function to instantiate a prefab. What I meant to do is ask you about the set profile. Okay, so yeah, so the city setup works in a way that you take one of the prefabs that we have ready, for example the Deluxe blocks physics, place it in the scene, and then set its profile to determine how the building will build itself. Okay, the reason I got confused a second ago is okay, we used instantiate, we also used initialize function in our code, so apologies for being a little bit confusing. Okay, so the script which actually builds our city that you're supposed to edit in problem 1 already has some buildings created, so that should have been a hint for you where to start. Okay, in this section called city buildings, you see there's already a nested loop which instantiates some building prefabs. This building prefab variable, which is defined in the beginning, it's one of the fields of the city manager class. So building prefab. It is exposed here in the city manager, and this is where we define, okay, this is the prefab we're going to use for, you know, this bunch of buildings. So yeah, obviously when you run it, it populates the scene with a number of buildings. So that should be very clear that this is the section that does this. So for building our walls, okay, well that's the quick approach would be, okay, we probably have to create something similar, but this time we won't be using the building prefab. We will be creating one that is specific for the city walls. So just to create a kind of a focus for us, I'm just gonna copy and paste this into the build city walls. Obviously this will not be correct at first. Okay. Why is it not correct? Well, first of all, this is creating a grid, so we're having two loops here that are nested inside each other. Quick question. How did this section, the city builders sections, determine for each individual building which type of the building it is?
Is it not a random variable?
Exactly, there is a random variable which is, well, we randomize first from a number between 0 and the length of the profile array. So coming again here as profile array here has been populated with 4 different tower profile scriptable objects. So this is how we end up with you know, somewhat varied city with you know, different types of buildings with different heights and some different rules, colors. So this is all defined with using the scriptable objects. Yeah, when you work, well, I'll get to it a bit later, but when you extend this system for yourself, for your final project, well, you definitely have to be on board with scriptable objects and using it to your advantage to introduce as much variation as possible into the city, or you know what's going on generally. So let me come back to this. Okay, so in case of the wall, the problem is a bit simpler. We don't need this randomization anymore. So okay, I can just delete this line. I don't care about this. Yeah. Where in the code do we actually set the building to a specific type? Well, let's have a quick look here. This set profile call. One thing that might be a little bit confusing here in this long line of code is okay, the order things happen. So when you look at a line of code like this, remember about the dot notation. So we're using this dot to access, go down a kind of a tree of properties and fields to and methods to access something from the original object. So the original object in this case is the object created using the instantiate function. So here I'm looking at my, I don't know if everybody can see this but in my IntelliSense hint here, it shows me the type of the type of the object returned by the instantiate function, and that type is game object. So I actually get, after I run the instantiate function, I get a game object reference. So after I've called this, I have an object that I can actually do something with. So I can access fields, call methods. So this is the dot notation in case that's still giving someone problems. So I can go down and pick any method pertaining to game object here. So for example, a game object would have a name, a game object would have a tag, a transform. So we've been using this, but just to maybe clarify in case that got lost along the way. So using the dot notation now here, I have the object. I need to actually get down from the object level to the component level. So let's have a look here. This is an example. I'm just highlighting one of the deluxe block physics. Okay, this is the component which is based on the object. So I have access to this whole lot here. This whole object, which contains a transform. It contains a mesh, a renderer, and some other functionality, including our deluxe tower block script. So the method that we need to call in this problem is the set profile method. This is not a function which is available for any old game object. It has to be a deluxe tower block object. So that's why we have this section here. We specifically ask for a specific type of component which is located on this game object. Now again, for some of you, like you saw the graph of the exam results, so there's a very widespread. So okay, I understand that I'm perhaps boring some of you to tears, but perhaps not. And then for some of you, maybe this is a bit that still kind of was causing problems. So after I call this function, this you can see also the return type of this function in the hint. So you see the get component method of the game object class returns a type deluxe tower block. So this is actually the script that we're interested in, and once we call that, we have access to the methods in that script. Bear with me now. I'm going to give you a slightly different perspective on all those things a bit later on today's class. But let's first get through the textual representation. So now I'm calling the set profile function for the building we've just instantiated and the deluxe tower block component on it, and I'm calling the set profile with the profile that I require. So this is the way you need to think about it. We start from left to right and end up with the final function that you want to call there. So this would select a specific entry. So this is an index to an array, the random number. Okay, I think I've the random number between 0 and the array length. Remember, you cannot call, you cannot access the element of array using an index larger than the size of the array. That also one of the things that you should be aware of. So we can simplify this at this stage. For our city walls section here, which we're starting to create now, we don't have an array anymore. We just have a single element here. We created this okay, yeah, we created this building profile, wall profile. So building profile is what again?
The profile is the positions in which each building is formed. Is that what it is?
Okay, well, precise answer. Okay, building profile is actually our scriptable object. So this is the kind of a packet of information, kind of an asset, which holds the blueprint for our building in this case. So a couple of arrays, a couple of variables, the height of the building, and so on. So in this case, for the city buildings, we had an array for them. Now for wall profile, we just have one profile here that has been given to us. The wall profile over here. And that's what you're going to plug in here in set profile. And again, most of you have managed this, so very good. Okay, so now we have we are instantiating the building prefab. Okay, the position is defined by this new vector 3. So the x, y, and z are given, and they are based on the loop variables, the iterators. The iterator for the first loop is an integer named I, and the iterator for the second loop is an integer named j. So let's see what actually happens if I run this. You can guess that it's going to be a big mess, but we'll get to the actual correct. Okay, just a second. Okay, so we see that our wall profile is actually created correctly. The only thing is they were placed at the same place that other buildings were already located. We didn't do anything to prevent this, so things exploded, and now we have a very messy game field. So let's start fixing that. Maybe a quick peek again into the instructions. So in the problem description, I gave you this quick overview. Of what we expect to build. So okay, so the wall is supposed to start here at the lower left corner at -6, 0, -6. Why 0 here? Because it's at ground level, of course. And the upper right corner is at 6, 0, 6, so this would be the x at 6, z at 6, and y at 0. So there's many ways to do this. So I could either create separate sections which build each of these individual walls, or I could maybe try to make a slightly more clever loop. Well, you have plenty of time to experiment with that. Let me try something. Okay, let me go with the version that I provided for the solution in the repository. Which was to have a loop, which the outer loop, which is only having 2 passes. So I want to basically only this outer loop. I want this to only run twice, and I want to start straight away with -7 on the x. Remember, I here at this stage is the x variable. So I want to start with -7 here. I want to make sure this isn't larger than 8, and I'm gonna increment by 14. So that's this is only if you think about it, This is only gonna give me -7 and 7 in the two passes. So the first time it's just gonna start with the -7 value, which is obviously less than 8. So this will iterate. The internal code is gonna be executed, and then after that we increment by 14. We're gonna end up with +7, which is still less than 8. So we already have our two passes. Let's try that. Let's see what happens. Okay, so something happened. So on the x-axis, the horizontal axis when looking from the top view, I've got two strips of buildings on the left and right hand side. Why are those strips kind of staggered? Well, because we have an increment in the inner loop, which is 2. So let's just modify that. I'm gonna go from here. I'm gonna go from -7 to 8 here as well, and see what's gonna happen. Okay, so in this fairly simple way, I have already half of the city walls created. Any questions so far? Okay, but that's not enough. So let me just duplicate this loop and just take care of the other side now. How about I copy this whole loop? Just I can keep the same name for the iterator here, so I can also use j. This is a kind of a local variable for the iteration itself, so it doesn't exist outside of this for loop. So we're quite free to use it again. And I'm gonna just swap around the coordinates here. So I'm just gonna swap I for j and j for I in the second version of the line, and we'll see what happens. Okay, so we do have our walls, but there seems to be a little bit of overlap. It should be kind of clear after our physics lesson why things pop out of place the minute the game starts. Well, because they have colliders assigned with them and rigid bodies, so the physics system registers two objects at the same position and generates forces to prevent two objects staying in the same spot, and that's why we have a collision and messy corners. So how to prevent this overlap? Well, how about let's just cut this down on this second pass. I'm just gonna decrease the pass to go only from -6 to 6. Let's run that. Okay, and that's it. Problem solved. Oh, I think I actually made a bit of a mistake here. This wall is larger than what was asked for in the problem. Well, you can see that the gate is not matching with the wall. That's grand. Let us correct that really quickly. So I'm just gonna just change the numbers around, and this should be kind of clear if you play with this why I'm doing this. -5 and 6. Hopefully this time we will have a wall that matches the gate. Almost. Okay. we have some outlying bits which we need to fix now, so let's do that. They come from here, so this also needs to be changed. Okay, and that's it. That's the solution to the first part. So we've tested the understanding of the scriptable objects okay, I think did I miss something now? And a very simple example of a for loop to basically paint something. So we paint this wall on the game field, which then gets built from our starting blocks. Okay, a couple of students actually filled the blocks above ground, so I saw someone create a triple nested loop, actually building blocks high up, so that was also incorrect, because all you need to do obviously is just place the initial block and it will take care of the rest. That's how we set up our 3 tower block and the deluxe tower block scripts, so that they build themselves from the ground. Okay, so is there any more questions about the first project, the first problem? If no, then I'm just gonna move on to the second problem. So here we need to build our randomized castle tower. So this was slightly more complex in that we needed to create the specific tree profile for our building. The specifications were given here, so let us work through this. I'm just going to move it over to my screen so that I can see what I'm doing. So to create a new scriptable object, just to remind you, you can either use the create scriptable objects building profile. So that's one way to do this. Okay, let me delete this. Or you can highlight an existing, because this is an asset. So as with any assets, you can actually duplicate them. So I'm pressing Ctrl D, and suddenly I have a wall profile 1. I can rename that. In this case, it might be actually a simpler way to do something like this, because it's already partially populated. So let me go into this tree profile and start editing it. Like we saw in the scriptable object script, there's a couple of arrays there. Ground blocks, main blocks, alt blocks, which we never used, roof blocks, ground materials, main materials, roof materials. So we mainly specify the meshes and the materials that are used for the building. And also there's a field here called max height. So the instructions specify for ground level blocks, we want blocks and arches. So we want this to randomize between those two types of buildings, blocks and arches. Okay, I've got that done. Now expand the main blocks, which were supposed to be blocks and arches. Again, the same types of meshes. For roof blocks, okay, alt blocks we don't really care, but it's good that we already have some element in there. Probably safer not to have 0 size arrays, just in case our code doesn't take care of accessing an empty array. So for roof blocks, I need 2 elements as well. So I'm just increasing the size of this array to 2 in inspector and adding, let's say, dome with base and slope meshes. Okay, so these are all blocks that we have available to play with. Now the materials. For ground blocks, we want to have the gold and white material. So the array needs to be size 2. Okay, I just use the search function to find the material. Okay. For the main blocks, the same. And for the roof materials, we want the blue material for blue domes and slopes, so make the roof a little bit different. Okay, so that's it. We have our tree profile. So that's that part of the problem, and I think again, like majority of you got this part right. So let's move on. In the city manager script, I believe we already have the tree prefab variable there to use. So tree block is the prefab. So now, okay, this is the actual prefab, which is using our tree tower block script, and this needs to know what its starting profile is. So just to make sure. Yeah, the tree, I was just checking if I provided this for, yeah, I did make this for you already. So, okay, so this needs to be a tree profile, okay? Just to be on the safe side, I'm just gonna enter this prefab, so now I'm editing the prefab itself, and make sure that the profile in it is the tree profile. It is. Now I can exit the prefab, go back to the scene. And we have this tree block placed in the center of the scene because there's only one castle that we're building. Okay, I'll just check. Yes. Okay, so if I hit play now, let's see. Let's increase the maximum height just to make the building stand out. At the moment it's still building a standard tower. So this looks good. It's building our using the correct profile. With max height 20 you will probably go over our limit of 15 because our array for the city planning only reaches so far. So let's see what happens if I restart this with a smaller value. And yes, we have the roof now, so I think that proves that our new tree profile is working. So okay, that's that part of the problem. And the next part is again to modify the tower growth behavior. And again, I've already copied the relevant sections of code in as your starting point. So again, you didn't need to technically write any code. It's just understanding what's going on and modifying the right arguments to the right functions. So this description is kind of just explain what's happening there. This has already been implemented in code. You don't need to worry about this part at all. Meanwhile here, okay, if the tower block, the newly placed tower block is above height of 5 meters, we randomly add things to the north, south, east and west and upward. We do it in a randomized fashion. So let's have a look at the code that does that. Okay, here I'm in the tree tower block script, and just going into methods. This is the section of code that is of interest. So okay, it seems a little bit large, but if you have a quick scroll through it, you see that these segments of code are identical. They are placeholders for the 4 different cases that are described here. So we have a section of code for the north, for the south, for the east, and for the west, and also obviously upward, which was already there. So you should at this stage be familiar with this tower block script enough to see, okay, this is the section below 5 meters altitude, and this is the section above it. This here is the block built above the current block, so this doesn't need to be changed. That's right here, okay, and modify code indicates that you only need to change these 4. So what needs to happen? Let's see that the first block is going to be the block built to the north of the existing block, and not higher, but on the same level. So if you look at the picture here, okay, so we start with a block in the center, and then let's say this is the block to the east, this is block to the south. So let's just try with the north block first. What is north in our game coordinate system? No, that is east. This is the top view, so north would be, you see the Z arrow is pointing north. Okay, so we know we have to look at the Z coordinates. Let's start with the position first. So this is where we actually place our child block. So the current block, we know something about its position. X, Y, Z. They were made into integers by rounding from the actual block transform position X, Y, and Z, and we added 7 there as well, so that it matches our array mapping. If that's unclear, I recommend if you go to the description of the city building array, but the main idea there obviously is that we build in our scene, our city is centered around 0, but when we deal with our city planning array, it starts at the lower bottom corner. So this would be like the 0, 0 index for our array. So when we're at 0, 0 in the world coordinate, it's already 7, 7 in the array reference frame. It's shifted because our city is shifted. Our city doesn't start at 0, it starts at -7 in this case. And the whole array for planning is only size 15. If you look here quickly in the fields, sorry, that's in City Manager, of course. This is our city array, bool of size 15 by 15 by 15, so a square, a cube, a spatial cube of booleans. So coming back again to this section of code, do we need this y+1 at this stage? Okay, this is the set slot, so maybe let's not get. Should this be vector up? Well, this means that we instantiate the next block above the current block. Well, we just decided that we don't want to do that now. We want to, in this case, if the random is we've thrown the dice, like giving us a number between 0 and 10, and if that number is less than 5, so it's kind of like half of the times we want to build that northern block. This setup is in place. It's a little bit weird, maybe using 10 when I only need between 1 and 2 in this case, but having this set up like this allows us to play with probability a little bit easier. I could change this to 8, and this would be much more likely for the tower to grow specifically in the north direction. So this is already preparing you for like different variations that you can play with in your final project. So vector north, forward. In this case, the z-axis is the forward vector. So okay, I could do that and leave it like that, and it would probably do something. Let's try it, because that's a problem that a lot of you ran into. Okay, so we see that we have built indeed a northern block. It only happened once during the whole building process of the tower. Maybe we can increase the probability here just to be testing it more thoroughly. So I'm gonna change this to 8 now and run this, and I would expect many more branchings off to the north. And indeed, it seemed to have happened, a bit more often. Okay, obviously it's randomized, so at every execution of the tower building algorithm, it will look a little bit different. Okay, so let me, let's say I'll leave it here at 8. That's fine. Okay, maybe let's just, since we're at the position stage, let's just do it for all the blocks. So, okay, this is north, so that's great. Let's do the east, so that's gonna be right in this case. That should also be clear by now, the axis, the coordinate axis, and how they, okay, so the forward axis is the blue axis, it's the z. In this case, the x is the east, is the right vector, so we can use that. Vector 3 right. Okay, and then the next slot would be, let's say we'll go for south, so we can use back. It's also possible to use minus vector 3 forward. That would have worked as well, because these two vectors are just opposite of each other. So let's go with back, since that's already ready for us to plug in and use. And then the last one is going to be left. Okay. And let's see what happens. I would expect actually a lot of exploding blocks at this stage, because we didn't really control what's happening with our placement, so there might be blocks overlapping. So this is what happened. Okay, in this case we were lucky. Okay, in this case we were also lucky. Again, wow. So that would actually seem like it's not too bad. Have another look at this. But that's only because I've modified my max height to 13, so I'm gonna increase it so that we give the tower a little bit more chance to mess up, more iterations. I'm gonna increase the frequency just to make it a bit more clear. we can see though that the tower isn't really unfolding the way we expect it to be from the requirement picture, from the specification. So why is it so restrictive? Why does it only let me kind of like go along one branch? You see that we didn't actually end up with any branching in this case. Perhaps it's because the city array doesn't know that. Okay, so we didn't actually modify our check slot to correspond to the position of the block we're trying to build. So here we've modified the position to be to the north of the existing block, but we haven't done anything with the check slot method. So for this to actually correspond to the block we've just placed, we need to add the one to the Z coordinate in our check slot here. And in set slot, which is, if you remember, a way to update the city planning array so that the other blocks know that something has been placed there, we should also modify this Z coordinate. So this is the core of what we were testing in problem 2, whether you understand this correspondence between the blocks placed in the world and our internal model, the array that holds the positions. Okay, so that exploded immediately. So let me go back to my standard probabilities there. So again, half a chance that a given branch is going to be built. I reduced this to 5 again. And since we've done this check slot and set slot adjustment for the northern block, why not do it for the other ones? So here to the right, vector 3 right, so this is the east block. This means that this has to be x plus 1. In this case, backward, that would be the z coordinate again, but -1. And in the set slot line, z -1. Left, x -1. Okay. Okay, so that's closer to what we expected. This is actually almost correct. Anything still unclear about this bit? Like okay, if you have a closer look at the instructions, there's a section here about those floating arches. So no floors in certain castle chain. What that means is, okay, you see that we've instantiated arches, a block which doesn't have a floor in itself. So how do we prevent this from happening? Well, first of all, have a look at our tree profile scriptable objects for the main blocks, because these are the blocks that we're talking about now, and we see that the arches block is the second element in the array. So element 0 is the standard cube, and then arches is this block here that is causing us problems. So let's have a look in code. Where do we actually define what mesh is being used for the new block that's being placed? Okay, so this is this long line here. Again, I'm going to just go through this. So bear with me. Again, for some of you this will be quite obvious. Again, child object in this case is the block that we're building. So the next block that's being placed. We need the tree tower block script. We need to access method from the tree tower block script. So we do a get component on that object. Now we have a tree tower block class access. We can use the initialize method. This is the one I was talking about earlier. Let's go to implementation of this. So this is where the mesh is assigned. So the arguments to these functions are existing recursion level. So exactly like how old along the tree is this block. So this restricts the building of the building. This restricts the growth of the tree along the branches. So both this will define. If this is a low number, this will mean that we can still build many blocks starting from this. If this is a high number, we'll probably run into the maximum, which is this. In this case, we've defined as 20. So the second argument is the material that's being used, and the third one is the mesh. So here we see in this function we actually assign the mesh in the tree tower block that's being used later. So the function which I just showed you, okay, this is a function call specifying the arguments we're interested in. So if you remember, this is the recursion level. We increment by 1 to stop the growth of the tree eventually. Then we specify the material. So this is where we select from the roof materials array from the scriptable object data. And this is where the mesh comes in. So we've randomized and we pick either 0 or 1 in this case, because what is mesh num? Mesh num is the roof blocks array length. So in this case, what value is that going to be? It's going to be 2, because that's the length of this array. We only have, for roof blocks this is going to be 2. We're interested in we're interested in this line, so main blocks. So this is also 2. So this mesh num value. Okay, if we look at the way the random function works, this for the integer the integer arguments. It's inclusive for the minimum argument and exclusive for the maximum argument. So it means this will, at the end of the day, this will be value 0 or 1. We don't want that value 1 to happen there at all, because that's the arches. So the easiest way to actually fix the problem is just to predefine. This is always going to be the main block. This is always going to be the cube. We only modify it for the blocks which branch out to the north, east, west, and south, because these are the ones which have the danger of actually creating an overhang. I missed one. Yeah. 0. Okay. This is the block which is built above the current block, so we leave that because we do want some arches to remain in the tower, and these will be only the blocks which are built on top of the existing block. So let's test if this worked. Okay, I don't see any arches. What happened there? No, there are arches. Okay, so I have a feeling that I've removed too many now, so let me just check. Oh, okay. So no, that's correct. Okay. Yeah, I did make a mistake there. I do need the random for these blocks. Okay, so that's pretty much it. That's the problem solved. For the third problem, okay, the nuke city from orbit, this was really more testing your understanding of a text description for a problem. So we want the player to fly high up into the stratosphere, so the minimum altitude of the player's hover car from the ground level at which the explosion should be triggered should be 30 units. So I already gave you pretty much a complete code for this. Let's have a look at it. You can see here, if you look at the code, we have our nuke prefab, the object that we need to spawn under certain conditions. We have our nuked boolean, which is starting as false. This is just a flag to tell us whether we've already triggered the spawning of the object. And then in the update function, we just run this check. And in the code I gave you, this was the tricky bit. The code I gave you uses magnitude field of the position vector. So what exactly will this do? Does this correspond to altitude? Well, when you think about it, and you should know this by now, magnitude is just the length of the vector. So if I take the position and of the car and calculate the length of this vector, does this, if the length is larger than 20, does this mean that the car is above 20 meters? Well, no, because as you can find out by running it, it will also trigger when we move back from the city. So I guess this was a little bit of a trick question there. You didn't need to actually do quite a lot of coding, but you needed to understand what's happening. So yeah, I moved back and this got triggered, so this isn't correct. So if you didn't modify the code and left it like this would have not been credited. So what we need to do is make a very small change. Transform position.y. This would be the y coordinate, the vertical position for our car. So I'm moving away from the city, and now it didn't trigger, so that's good. Meanwhile, if I just fly directly up, this got triggered. So that's all that needed to happen. So okay, so that is it. This was the entire contents of the test. if you still have any questions and you don't want to like air it out in the open, shoot me a message, DM me. I should be available today from about 5 p.m. if you still need to ask me something. But for the moment, let's take a break. So let's take 10 minutes and come back 20 past 11, please. All right.